All right, Chapter 1, Lesson 4 is proportional and non-proportional relationships. In the warm-up, it says Miss Cochran is planning a year-end party for her students. Ace Pizza offers free delivery and charges $8 per medium pizza. Complete the table to determine the cost for different numbers of pizzas ordered. All right, so here are the costs for the rest of the pizzas. So 16 for 2, 24 for 3, 32 for 4, and 40 for 5. Number 2 says for each number of pizzas, fill in the boxes to write the relationship of the cost and the number of pizzas as a ratio in simplest form. So for $16 for 2 pizzas, if I simplify this by dividing by 2, we're going to get what over what? 8 over 1. And $40 for 5 pizzas, that would be 8 to 1. Very good. So what do you notice about the simplified ratios?
All the numerators equal 8 and all the denominators equal 1.
So all of the ratios are equal. Very good. So today we're looking at identifying proportional relationships. Please make sure you write down these definitions. Two quantities are proportional if they have a constant ratio or unit rate. For relationships in which this ratio is not constant, the two ratios are non-proportional. So when I say constant, that means they are equal all the time. Okay? So here, all of the ratios above are equivalent ratios because they all have the same value. These are the cost for pizzas in our warm-up, and they all of the ratios simplified to $8 for 1 pizza. So because they all have the same value, they are equivalent ratios. So Andrew earns $18 per hour for mowing lawns. Is the amount of money he earns proportional to the number of hours he spends mowing the lawns? And please explain. So here, the first thing we want to do is we want to look at the table. And in the table, we have some ratios. In order for us to determine if they are proportional, we want to convert them all to unit rates. Is everybody with me? So here, 18 to 1 is our first rate. That's $18 for 1 lawn. That's 18. Here I have 36 to 2. So $36 for 2 hours. That's our second rate. If I simplify that, that's going to be 18 to 1. 54 to 3 simplifies to 18 to 1, and so does 72 to 4. That also simplifies to $18 for 1 lawn. So, because each one of our rates simplifies to the same unit rate, it is a constant ratio or a constant rate, right? So that means that the money he earns is proportional to the number of hours he spends mowing. Is everybody clear with that? All right. So now let's do this got it problem together. So, at Lakeview Middle School, there are 2 homeroom teachers assigned to every 48 students. Is the number of students at this school proportional to the number of teachers? And explain your reasoning. So, the original, if I'm going to set up my original rate, we're going to compare students to teachers. Okay? So when we compare students to teachers, our original rate is 48 students to how many teachers? 2. To 2 teachers. Now, if I simplify that, then it simplifies to 24 students to every 1 teacher. Don't forget to write your units. All right, so here we end up with 24 students for 1 teacher. It says here there are 2 homeroom teachers assigned to every 48 students. So that means for every 48 students, there are 2. So that means for every 24 students, there's 1. So would this be a proportional or a non-proportional ratio? This would be proportional. Very good. All right, so Uptown Tickets charges $7 per baseball game ticket plus a $3 processing fee per order. Is the cost of an order proportional to the number of tickets ordered? And explain. Once again, in order for us to find out if it's proportional or non-proportional, you're going to simplify all of the rates to a unit rate and then compare. Are they the same or are they different? If they're the same, it's proportional. If they are different, they're non-proportional. Very good. So here, for 10 to 1, that's going to be 10. 17 to 2, when we change that to a unit rate, it's going to be 8.5 to 1. 24 to 3, that simplifies to 8 to 1. And then 31 to 4, that simplifies to 775 to 1. So since each one of those unit rates is different, is this proportional?
No.
This is non-proportional. Simple? All right. So we could also use a recipe shown for fruit punch. Once again, we can create, this is a complex fraction, right? When we create the ratio using the complex fraction, we can still simplify to a unit rate. So this is 1/2 to 1. This is 1 to 2, which simplifies to 1/2. 1.5 to 3, which simplifies to 1/2. And 2 to 4 simplifies to 1/2. So in this recipe, is it proportional or non-proportional? Very good. That is proportional. All right. So let's take a look at the Scott problem. At the beginning of the year, Isabel had $120 in the bank. Each week, after that $120, she deposits another $20 in her account balance. We want to know, is her account balance proportional to the number of weeks of deposits? And we want to use the table to explain our reasoning and explain our reasoning. So, she originally had $120 in the account, right? So after the first week, she puts another $20. So how much is she going to have? 100. She has 20 plus the other 120. So that's 140. Very good. And then the next week, she deposits another $20. So she's going to have 160. And then the next week. Very good. She will have 180. Now, we want to change all of these to unit rates. So, my first rate is 140 to 1. And that's going to be $140 per 1 week. Right? The next one, the next ratio or rate is going to be $160. $160 in 2 weeks. When I simplify that to a unit rate, what's that going to be? $80 in 1 week. Very good. And then finally, our final ratio is $180 in 3 weeks. So as a unit rate, that's going to be what? Very good. So that's $60 in 1 week. So now, when I look at each one of my rates, are they constant or are they not constant? They are not constant. So that means, is this proportional or non-proportional? This is non-proportional. Very good. Here, the tables shown represent the number of pages Martin and Gabriel read over time. Which situation represents a proportional relationship between the time spent reading and the number of pages read? So once again, we're going to take each of the rates, and simplify them to a unit rate. Okay? Actually, here we're just comparing the fractions. We're not even changing them to a unit rate. We're just simplifying the fraction. So here, 2 to 5, 4 to 10, and 6 to 15, those all simplify to what? 2/5, 2/5, 2/5. Does everybody see that? For Gabriel's reading, 3/5, 4/10, and 7/15, 3/5, 2/5, and 7/15. Is this proportional?
No.
This is not proportional. So the only one that is proportional is Martin's reading. Is everybody clear with that?